we can write linear equations using the greatest common factor. What I've done here in this table is taken different values for x and y, -2 through 3 in both cases, and plugged them into this statement 42x plus 30y. And in the grid are the results of 42 times x plus 30 times y. What I'd like for you to notice is that each of these combinations is a multiple of 6, and the greatest common factor of 42 and 30 is 6. This is no coincidence. The question that we're going to look at is, when does ax plus by equal the greatest common factor of a and b? We're going to assume that a, b, x, and y are integers, and it turns out that all the values of a times x plus b times y are multiples of the greatest common factor, because the greatest common factor divides a and b. The smallest possible positive value for ax plus by is the greatest common factor. So the question we're looking at is, when does ax plus by equal that greatest common factor? First, I'd like for you just to use guess and check to find some integers for x and y in the following. You should probably pause the video here and maybe find more than one answer, more than one pair of x and y that will work. Now what I'd like to do is use the Euclidean algorithm to find integers x and y so that 22x plus 60y equals the greatest common factor of 22 and 60, or with this other pair. We're going to examine the 22 and 60 example. The first step is to use the Euclidean algorithm to find the greatest common factor of 22 and 60. We get 2 through this process. The next step is to pick a number to be a and a number to be b. I used a for 22 and b for 60, and just make those substitutions briefly, and that's what you see in the right-hand column here. Next is to take the first equation and solve for the remainder so that you have the remainder in terms of a and b. So I take the statement b equals a times 2 plus 16 and get 16 equals b minus 2a. Then I substitute that in for 16 in the next statement. So a equals 16 times 1 plus 6 becomes a equals b minus 2a times 1 plus 6. I work that out and solve for 6, that remainder, and get 3a minus b equals 6. Then I take the 16 and 6 and substitute those in the next line, so we get b minus 2a equals 3a minus b times 2 plus 4. And now we solve for 4, and you get 4 equals 3b minus 8a. In the next line we have a 6 and a 4, so I substitute the 3a minus b in for the 6, the 3b minus 8a in for the 4, then solve for that remainder of 2. When all the algebra shakes out, we get 11a minus 4b equals 2. We found 11a minus 4b equals 2. Since the greatest common factor of 22 and 60 is 2, and a was 22 and b was 60, that means 22 times 11 plus 60 times negative 4 is that greatest common factor. Therefore, x equals 11, y equals negative 4. That's one solution to 22x plus 60y equals the greatest common factor of 22 and 60. It's not the only solution, and you can either think of that as a good thing or a not so good thing. And here are a few solutions to those second set of exercises.